Okay, guys,
We are the TN Department of Energy. That is Kori, me, and Kylie. Next slide, please. To whomever it may concern, upon seeing your request, we began working immediately on houses A, B, C, and D to determine which would be the most inexpensive, efficient electrical setup for the upcoming neighborhood. To do so, we had to first figure out the resistance and power before making a linear equation for each house. To use a linear equation, simply plug in the numbers of hours you need to X. In this PowerPoint, we used the average 730 hours per month, which led to plugging in the number 182.5 for each week.
These are the equations for house A, B, C, and D.
This is the graph. We just plugged in.
Yes.
We plugged in 182.5 in each one of the equations for up to 4 weeks, and as you can tell, you can see which house was the most expensive out of them all, which was house B, and the least expensive was house C.
The numbers on the side are US dollars, so 20,000. This is the overall ranking for the houses in case you wanted to put more than one: C, D, A, and B.
okay. So I appreciate you telling me about the houses, and I happen to see that you have them listed there on which one. So again, in looking at the houses, you said C, D, A, and B. And how did you come to that conclusion? Was it based graphically? Was it how did you come to that conclusion, so we'll know how much of a difference there was between the houses?
What, the formulas or the plugging in?
Either one. You tell me.
The formulas, we saw pictures of the house that already listed the resistors, the inductors, the capacitors, and the voltage. To find it, we had to find the total resistance of the house using the 1/RT formula. After we found the resistance, we had to find the voltage to, so that was to find the power overall. The power is what you needed to find for we did the power and we multiplied it by the money per minute, basically, per kilowatt. And so, really the voltage on every house was, it was 120. So all 120 times 120 times our 1/RT got us our power. And then each one we multiplied by the house, like the price for each house. So usually it's like 0.07 or 0.02 or something.
Okay. In a previous slide, I had seen that you have these formulas. How did you come up with those? Because I know in looking at the original housing documents, it had mentioned that there was like 60I and 25I. What is that? And why is the I not represented there?
I means imaginary numbers. It's basically the heat from the power. That's not necessary in finding out because it ends up going away. It's not, you don't have to pay for the I. So even though it is on the equation, we didn't put it up there because it was unnecessary to the graph.
Oh, okay. So in those graphs, does it represent anything to do with the heat, or is that just the voltage of the
That's just the voltage, the heat you don't have to pay for, and the graph is strictly for your payment and all that. The company will handle the excess heat for you.
Okay. Well, the graph was that's very informative. I can see exactly where you're going. I can see if I need to come up with more for each month, because you're saying, how many hours did you say is in each month?
Average is 730.
Okay, so I can come up with different months if I needed to. But I am kind of curious because I'm not a math person, and I was curious if I was working with I's, what do I have to do to work with I's in these equations? Because it did have 60I and 25I.
Well, your I's can never be in your denominator, so really you have to just you have to work it. You have to work your eyes all out of the denominator. You can't have a like imaginary number to divide by.
Okay, and when you said opposite, am I talking plus or minus? What am I doing
Like
there?
if it's multiplying,
If it's negative I, to get it back to the numerator, you have to do it times like positive I. So just make sure the i's are negative, not the actual numbers, just the i's need to flop.
Okay, well that was just interesting because I did see the original documents and they had eyes in them, and I was curious where those went. So thank you so much. We appreciate your expert opinion, and we will definitely use this for our next presentation that we have to decide if these houses will work for us.